Okay, this is G. So when we're talking about electron configuration, we're talking about filling the orbitals. And the way your yellow sheet works is that you're going to go from the 1s, and then you go to 2s, then it goes to 2p, 3s, then 3p, 4s, then 3d, 4p, 5s. And then you go up to 4D. So it's important to go in that order. So we're going to talk about page 1 of your Unit 5 packet. So your sublevels are S, P, D, and F. So your orbitals, S has one orbital, and we represent it this way with the line. P has 3 orbitals, so we do 3. D has 5, and F has 7. Okay, so I'm not going to draw that out. So each orbital can contain 2 electrons. So when we fill these, so S has 2 electrons, P has 6 electrons, D has 10 electrons, and F has 14. So let's move on to where it says principal energy level. When they're talking about principal energy level, so principal energy level means that at principal energy level 1, there's only the S. You're looking at your gold sheet, and then principal energy level 2 has S and P, and then principal energy level 3 has S, P, and D, and then as you can see 4 has S, P, D, F. So it's asking how many electrons. So S has 2, this has 6. So we have 8 because P has 6, S has 2, and then 3 has 18. So you should be able to do principal energy level 4. So on the bottom, it's just asking you to do electron configuration to 5s. So basically, you're following your chart. So you do 1s2, 2s2, because I only can put 2 in the S, then 2p6. Then you follow the chart to 3s2, and then 3p6, 4s2, and then you do 3d10, 4p6, and 5s2. All right. So let's do some examples from the worksheet. So let's go to page 3. So it asks for the electron configuration for potassium and cobalt. The potassium has 19 electrons. So basically, you can do orbital notation, or first, and then electron configuration. So if I was doing this, you're basically filling these until you get to 19. So I've used up 2s, now I've used up 4, 2p, now I've used up by hundred, we go across and then down. So now I've used up 10, and then we go from 2p, we go to 3s, and we use up 12, and we go to 3p, now I've used up 18, and after 3p we have 4s, and we put 1 arrow. So now we have 19 electrons. So this means it's partially filled, okay, so, and it doesn't have a pair. So we would say it has one unpaired electron. So to write the electron configuration, you can do 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, and that's our electron configuration. All right, let's do cobalt. So cobalt has 27 electrons. Right? Let's make sure that's right. So we're going to do the same idea. You can go right to the electron filling, because that's what it's asking for. So you go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now I've used up 10, 12, 18, 20. So now we're going to 3D. So we need 7 more. So that puts us at 3D 7. So it's also asking how many unpaired electrons you would have. So I would look at the last part of it. So we know that D has 5 orbitals. You go across by Hund's rule. Each arrow represents an electron and then down. So it ends up that we have 3 unpaired electrons. Okay, so I hope this is helpful. We'll work on this more when I get back.